Well, hello guys. Good evening. This is our December week 2. Okay, nice to see you all again. Hi Gabriel, hi Jala. There's only 2 of you currently. Okay, so what are we doing today? Today we are going to chapter 11. Okay, this chapter, I think some of you have learned this in school already. And even if you haven't, you have at least learned this in maths, right? So this is a mathematics chapter. It's our linear motion, right? If you still remember, what is your distance and displacement? What is your speed and velocity? You hate this chapter with a passion. Why though? Why? This is so easy to score an acceleration. I mean, there's nothing to memorize here. Have you so confusing? Okay, Gabriel, I think you learned this in maths, right? Have you? Or maybe you had a bad experience with it. Hopefully I can change your mind after today. Okay, any of you done this experiment in school? This sliding trolley thing with the ticker timer thing. Did you guys do this in school? I'll talk about this later. Okay. When you see these dots, okay. Ignore this first. Okay, ignore this first. It looks harder than it is because it really is. It's really easy. Right. So let's jump straight to the point. Today will be a very straightforward lesson. Gabriel, try to look at this with an open mind. Try not to hate this. Okay, maybe you have past traumas. Okay, I understand. Right. Anyway, so what's the difference between distance and displacement? They are essentially the same thing. They are just slightly different in terms of okay. So your distance is the total path you travel. Displacement is the shortest path, which means a straight line. Okay, straight from the starting point to the ending point, that is your displacement. Right, so take for example here. I start from this location. I go here and here and here, and I end here. This is my final location. So when we calculate the distance, we want the total thing traveled. That means 5 plus 5 plus 5. So the total distance is 15, right? But for displacement, we don't care how long you travel. We don't care what path you took. I just want the straight line from start to ending. So from start to end, I draw a straight line. This is my displacement. That would be 5 meters. Right? So essentially, they measure length. Both distance and displacement, they both measure length. The difference is one is the total length, one is the straight line. End of story. Okay, nothing to say here. Right? So let's jump to the next one. So, Gabriel, are you okay so far? Are you okay so far? Should be very simple, huh? Okay, so what about speed? Okay, when you take distance, you divide by time, you would get speed. So distance is the total, right? So speed is also for the total. Whereas velocity, this is displacement divided by time, and you get velocity. So displacement is a straight line distance. So velocity is the straight line speed, if you put it that way, right? So essentially they are the same thing. It's just that technically they are a little bit different. So this is very easy to remember. So okay, some students, they have problem memorizing this. They say, oh sir, I can never get this right. Okay, very easy. You look at your dad's meter when he drives. When he drives as a meter, right? Okay, maybe he drives 110 on a highway. Usually you see on the highway, they will say that 110 kilometer per hour is the speed limit. Right? So you see, distance divided by time. Right? 110 kilometer per hour, that means for every hour, I am traveling 110 kilometers. So 110 kmh. Right? So this is the speed. But we don't use this unit, we don't use kilometer per hour because it's too big, and plus we use SI unit. So the SI unit would be meter per second, right? M divided by S, so meter per second. You can write it this way too. It's the same, right? So what about the next one though? Okay, what about the average speed? This is just the same thing. We just take the total distance divided by the total time. Whatever, okay, whatever. If you want the definition, very easy. Whenever you divide by time, we use the word rate of change, right? So since it's distance divided by time, so it's the rate of change of distance. Rate of change of distance. Whenever you see divide by time, you use rate of change. Okay, so really easy. So let's do some really simple exercise, right? So calculate the speed of the runner at A. So what is the speed of this person here? You take the distance, you divide by the time. Okay, so 10 divided by 2, right? You would get 5. Oh my God, so easy. Okay, well, I'm sure in your school exam it's not that easy lah. It will never be this easy. So next, B, you have 50 meters in 6 seconds. So 50 meters divided by 6. So you would get 8.33. I think. Check your calculator, guys. I'm not too sure. I'm not too sure. And then average speed. What is the average speed? Average speed is when you take the total distance divide by the total time, right? So he ran 100 meters in 10 seconds. Wow, it's pretty fast. All right, so 100 meters divided by 10 seconds, you would get 10 meters per second, right? Something about this average speed, guys. Okay, pay attention here. Something about this average speed. This thing has no meaning. This thing has no meaning. Okay, what do I mean? Just because we know that the speed is 10, doesn't mean that he starts at 10 and he ends at 10. All right, nobody runs like that. You start at 0. Okay, your speed at the beginning is 0, and as you go faster, as you run, you go faster, you accelerate. So this 10, it doesn't mean anything because this 10 is like telling you, oh, they start at 10 and then they end at 10. He is running at a constant speed, which is no, okay, it doesn't make sense, right? So it's like this lah. Okay, it's like this. You know, your car has an average speed on the meter. Depends on what car you drive lah. Okay, if you drive like a, I don't know about other cars, if you drive a Volkswagen, your dashboard there, after you drove for one journey, at the end, they will show you your average speed. That thing has no meaning whatsoever, right? Because if let's say I drive from KL to Penang, for example, if I drive from KL to Penang, if at the end of the drive, when I reach Penang and I shut off my car and I see average speed 100, that doesn't mean I go 100 all the way, isn't it? Because it's pretty stupid. When I start driving, I don't immediately fly 100. Because if I do, I don't even stop at traffic light. I just go all the way to the highway with 100. And then on the highway, I keep driving at 100. You see, that doesn't even mean, that doesn't mean anything. So this average speed, then you might say, sir, then we calculate this for what? For fun, lor. For fun, lor. It's like your school exam average marks. Every year after your final exam, they will give you your average marks, right? Okay, let's say your average is 60. So this 60 means nothing. It doesn't mean that your BMBI is 60, your science is 60, your maths is 60. You are equally okay at every subject. No, you are maybe 80 at science, at maths or science, and then you are like 40 at CERNI. Okay, you suck at something, you're better at something. So this number, it doesn't mean anything. It has no meaning whatsoever. Right? If you get what I'm trying to say here. So really simple. So next, a student walks a distance of 9 meters from O to B in 18 seconds. So this is 18 seconds here. And then he then walks a distance of 12 meters from P to Q in 20 seconds. So 20 seconds here. So what is the student's speed as he walked from O to P? Okay, from O to P, that would be distance divided by time. Right, 9 meters in 18 seconds. So that would be 0.5 meter per second. And then from P to Q, same thing, distance divided by time. So you will get 0.6 meter per second. Okay, next O to Q, the average speed, that would be the total distance divided by the total time. So that would be 21, okay, 9 plus 12, divided by 38, plus 18 plus 20. So this answer, you should get around 0.55. Okay, check the answer, guys. I'm just getting it on top of my head. Okay, so far so good, guys. So far so good. So far so good. Should be very straightforward. Okay, I hope you like this a little bit more now, Gabriel. That's the best I can do. That's the easiest I can put this. All right. I think you hate this because of the graph, isn't it? This thing. Oh, because it's not by me. Oh, that's so nice. Okay. I mean, this is the killer. Right. This is next week, okay? This is next week. So let's enjoy the easy one for now, shall we? Okay, we don't go into all these headache one first. Okay, so let's talk about velocity. Okay, the velocity is the same thing. It's just as a straight distance. All right, so let's calculate the velocity of the car from O to A. So from O to A, so 4 meters in 2 seconds. Yeah, simple lah. 4 divided by 2. So this is 2. Next, A to B. This is 4 meters also in 2 seconds. So also 4 divided by 2. Well, this is a stupid question. So C, from O to C, from 0 to 12 in 6 seconds. So 12 divided by 6, which is 2. So this Myvi, apparently it's a Myvi lah, our national sports car. Quite impossible, isn't it? You might say, sir, how is a Myvi so obedient, keep driving only at 2 at the highway? It won't happen, okay? So this is a fiction. Right? Because usually you see Myvi on highways, they usually drive the fastest. Go on the highway, you shall find out. Okay. Anyway, next, a student walks 6 meters north in 2 seconds, and then he rests for 4 seconds, so he stops here at 4, and then he walks 8 meters east, also in 4 seconds. So what is the initial? Okay, let's cancel A and B. I don't want to do A and B. Right, so what is the average velocity? Right, when you see velocity, I only want from the starting point to the ending point. So instead of using the distance, okay, this is the distance. Right, let me write this here. The distance is 14 meters. Okay, 6 plus 8, what? Whereas your displacement, this, so that's what I want to find out, right? So you have 6 here and you have 8 here. Guys, how do we find this? This is basic maths. What's that formula called? There's a name for it. What is this? How do you find your this thing for your triangle? Anyone? Anyone? We're learning maths at this point. All right. So how do you calculate this? How do you calculate this? There is something called the Pythagoras theorem. Yes. Just in time for you to say that. So 6 square plus 8 square, square root, I should get 10. Okay, 6 square is 36, 8 square is 64. So 36 plus 64 is 100. So square root of 100, it's 10. Right, so this is 10. This is 10. So the displacement is 10. Right, so since they want the velocity, okay, velocity is 10 divided by, what's the total time? 2 plus 4 plus 4. That would be 10 seconds. So your velocity would be 1. Right, because we're taking the straight line. So you might say, sir, they are resting here. What? Why should we calculate? We want the total time. We don't care whether they are resting or doing whatever. Right? We just take the total time. So if they want the speed, then we will be using 14 divided by 10. That would be 1.4. Okay, see the distance, see the difference, and you see the difference. So speed and displacement, distance and displacement, speed and velocity, they are same but different. Okay, it's the technical term that is different, but essentially they are the same thing. Right, next, acceleration. Right, this is slightly more complicated. Okay, so what is this? Okay, let me sum it up. Let me sum everything up. First, you have distance and displacement. Right, the straight line and the total. And if you divide distance by time, you will get speed. And if you divide displacement by time, you will get velocity. Right, this is what we just learned. And if you divide both by time, you would get acceleration. So it's the same thing, right? So it's just one more layer. You see, speed at, okay, this is the first layer, distance, displacement is the first layer. Divide by time, we go to second layer, speed, velocity. Now we divide by time again, we go to the third layer, which is acceleration. So it's the same thing. So you see the unit is meter per second square, because I divided time by twice. You see, this is meter, right? This is meter per second. This is meter per second square. So divide by time, divide by time. So it's the same thing. But acceleration, they are slightly complicated, slightly, because we don't just take velocity and divide by time. We have to minus the velocity. We have to take the final velocity and minus off the initial velocity, and we divide by the time. So there's an extra step here. Can you see? We have to minus first. Right? You might say, sir, sometimes, most of the time, initial velocity is 0. What? Even though it's 0, you still have to write it out. It's part of the working, right? So in short, the formula is V minus U divided by T. Why is it V and U? Because V is final, U is initial. Because in terms of alphabet, right, U comes first, only comes V, right? Because A, B, C, D, F, G, blah, 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 U, V. So U first, then V. So you have your final minusing your initial, then you will get your acceleration. All right, it's not just like this. Okay, just now, when we take displacement, we don't minus because there's no need to. We just really take displacement, we divide by time. But our velocity is slightly complicated because we need to take the final minus the initial. There's one more step here. Right, so let's try it out. The bicycle in the figure above, which is stationary. Stationary means 0. Take note of the word. When they say stationary, that means it's 0. All right, sometimes they don't just say, oh, the bike starts at 0. They will tell you stationary. Of course, it's not that straightforward. So with the velocity stated above, the bicycle is pedaled with increasing velocity. So calculate the acceleration. So this is the starting. So this is the U. This is the final. So this is the V. So according to our formula, V minus U divided by T, that would be 4 minus 0 over 5. Okay, 4 minus 0 over 5. Right. Guys, take note. Listen here. Even if it is a 0, do not write it like this. I know it's a 0. Some teachers, they accept this. Some teachers, the fussy ones, they will say, oh, you did not write minus 0. You might say, sir, isn't minus 0 the same thing? No, because it shows the working. I know it sounds stupid. I know it sounds silly, but some teachers, they will penalize you for these silly marks. So just write everything out, right? So 4 divided by 5. So you get 0.8. meter per second square. Okay, remember it's 2, okay, not 1. Anyway, the next one. So there's a trolley here. So at P, they start at 0. They go to Q 5, R 15, and then S 10. Now, can you see? This thing is accelerating, then the thing is decelerating. The thing is slowing down. Right, so calculate the acceleration from P to Q. So since this is P to Q, the only one here, this is the U, and this is the V. Right, initial, final. So 5 minus 0 over 2. Cost 2 seconds. So you will get 2.5 meter per second square. All right, so if you guys have anything, please slow me down. I mean, this should be very straightforward for you. So QR, now 5 becomes the U. 15 is the new V. So 15 minus 5 over 2, I would get 5 meter per second square. All right, next RS, acceleration of RS. So now RS is here. This is the U, this is the V. All right, so you might say, hey sir, the U is smaller. Yes, that's correct. So it's 10 minus 15 over 2. You will get negative 5 over 2. You get negative 2.5 meter per second square. So it's negative 2.5. Right? When you see negative, what does it mean? That means the car is slowing down. Right? Negative acceleration is when the car is slowing down. So the next question, D, deceleration of the trolley from R to S. Okay, so this question, D, is the opposite of C. So there's no need to calculate. The opposite of negative 2.5 is 2.5. Right? When I have negative acceleration, I have positive deceleration. You guys get what I'm trying to say here? If my acceleration is negative 2.5, then my deceleration is 2.5. It's like if I have a company, my profit is negative 2.5, then my loss is 2.5. You get me? You get me? It's like if you do accounts, if you write negative 2.5 on your debit column, then you should write 2.5 on your credit column. If it makes any sense. Okay, it's the opposite, it's the same thing. Okay. Right, I hope you guys are following. I know it's very easy. I know it's very ignorable. Okay, very ignorable. You might say, hey, yeah, so all these things can we you know, don't care. So anyway, it's okay. Okay, let's talk about something more challenging now. Okay, let's talk about the ticker timer, right? So let's talk about the ticker timer. So you should be doing this experiment in school. Okay, you should be doing this experiment in school. So what is this? It's basically a trolley. It's basically a trolley. And can you see this slide here? So this trolley will slide down the slide, pulling a white color strip. Okay, pulling a white color strip. You might say, sir, what the hell is this? Okay, this is a machine. This is a machine that will draw dots on this tape. Okay, first of all, this tape, let's just call it, this is called a ticker tape. Okay, is it mentioned here? This is a ticker tape, right? I'll just call this a ticker tape. So your ticker timer is to draw dots on these ticker tape. All right, for what, leh? For your calculation of velocity. This device is to help you find the speed of the trolley, right? Because guys, because to find the speed of something, there's two choices. Okay, there are two choices. Number one, it's a speed camera. All right, it's a speed camera. Do you know what's a speed camera? Do you know what is this? Right? I'm sure some of your dad here has gotten this before. You forgot the speed limit and you accidentally step on the pedal and your car goes a little bit too fast. And lo and behold, when you pass by this thing, there's a flash so bright that it feels like lightning. Right? And next thing you know, they will mail this picture to your house, and that will be 300 ringgit, please. Right? So this is a speed camera. Right? And sometimes these police they're very sneaky. They'll just hide behind the poles. Right? They'll try to take your picture by using a makeshift camera. Right? So you get the point. Right? So there are two things to measure speed. Number one is the speed camera. Right? But of course, when we learn it in science, we have to learn the hard way first. All right? We have to use a more challenging device. That will be this thing. Right, so how does this thing work? As my trolley goes down, my paper will be pulled together, isn't it? As I pull this paper along, I will start to see dots on this paper because of this ticker timer. Right? Just by observing the dots, I can know how fast this is going. Right? You guys get what I'm trying to say here? Okay, visualize this. Visualize this. Imagine your dad's car is dripping oil. Okay, your dad's car is dripping oil. So as he drives down a straight path, you should see oil drops on the ground, right? On the road, right? So by looking at the oil drops, you can tell how fast is it going. You get what I'm trying to say here? So it's the same point here. Okay, your dad's car making oil drops on the ground is the same as this pulling this and making dots on this ticker tape. So we can use the ticker tape to find out how fast this thing is. Right, I have a question, guys. I have a question. If the dots are very far apart, what does it tell you about the speed? What does it tell you about the speed? Is the car going very fast or is the car going very slow? Dots are very far apart. Equal distance, equal distance. Okay, equal distance. If the dots are very far apart, does it mean the speed is very high or is very low? Okay, Jiale, are you with me? Jiale, are you with me? No, it's not zero. This is going down. This is going down. Okay, yes, hi. Okay, when you see very far dots on the paper, what does it tell you about the speed? You don't know. You guys don't know. Okay, you see, if the dots are very far apart, okay, I want you guys to visualize, if your dad drives down the road with the oil dripping, if the distance between two oil drops is very far, that means your dad is going very fast, isn't it? You get what I'm trying to say? If he drives really fast, you can see the dots, they are very far apart. Make sense? Makes sense. Your dad's car is dripping oil, right? If you drive really fast, you see the dots are very far apart. You see, the distance is very long. That means he travels very quickly. His speed is very high. You guys get what I'm trying to say here? Right? Comparison, if he drives very slowly, the oil will just drip, 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 drip. So we can see the dots being really, really close together. You get me? Guys, you get me? All right. You just imagine this is the ticker tape. This is the ticker tape. If I'm driving very slow, it looks like this. Can you see the dots are very close? Can you see the dots are very close? And if I drive fast, can you see? The dots are really far apart. So if I pull this quick, my dots will be very far. If I pull this slow, my dots will be very close. You guys understand what I'm trying to say here? You guys understand what I'm trying to say here? So as Gabriel just now, the one you said, acceleration or deceleration, it looks like this. Okay, so can you see if the dots are getting further, then this is acceleration. I'm becoming from slow to fast one. So this is acceleration. And the reverse, being very far and then becoming closer, 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 closer. This is deceleration. right? You guys understand? Can you guys understand? Please say yes. If you do. Okay, that's good. That's good. Right. But then of course, this is not just this easy lah, right? Because you have calculation here. All right, because you have calculation here. Right. Before I move on, guys, this is actually easier than you think. Okay, I'm not bullshitting you. Okay, first of all, when you look at this sticker timer, they will first put a setting here. It's 50 vibration per second, 50 hertz. Okay, 50 hertz. You might be scratching your head, sir, what does it mean? Right, that means this machine will draw 50 dots on the paper in 1 second. Right, 1 second, it is drawing 50 dots. So it's really fast, isn't it? It's like 50 dots in 1 second. That means I see 50 ticks in 1 second, 50 dots in 1 second. That means to find out one tick, I use 1 divided by 50, isn't it? Right, I use 1 divided by 50. That means every tick is 0.02 second. That means it takes 0.02 second to draw each dot. Okay, this will make sense, guys. This will make a lot of sense later. Please memorize this. Not really memorize, it's just understanding. So 1 divided by 50, right? So this is your one tick, 0.02 second. So what are we trying to do here? When we look at this strip here, you can know the speed, right? As we know, how do we calculate speed? We need the distance. We need the time, isn't it? Because distance divided by time is the speed, isn't it? So now, let's look at this strip. Okay, we already know this strip is 3 cm. Just measure using a ruler, you measure. We know this is 3 cm. So we already know the distance, right? This is the distance, right? Okay, now what about the time? The time is not given here. So how can I know the speed? Very easy, just by counting the dots. Because we know from up there, so can you see where this comes into play? We know that every dot, every tick is 0.02 seconds. So just by counting how many dots, that's how many seconds it is, right? So guys, pay attention here. When you're counting the dots, right? When you're counting the dots, please write this down. Do not count the first dot. Do not count the first dot. Why? When we count time, we don't count the second. We don't count the starting point. Okay, what do I mean? Let's say your tuition is from 3 p.m. to 6 p.m. Let's say 3 p.m. to 6 p.m. You don't say 3, 4, 5, 6. Oh, 4 hours. No, right? We don't count the 3. We start counting from the 4 because 3 is the starting point. We don't count the starting point. So it's 4, 5, 6. So it's 3 hours. This is why we don't count the starting point, right? And if you count this thing, it will be very coincidentally. Okay, look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually you will see 10, right? Your exam question will either be 5 or 10. Because let's face it, our OCD sense in us, we like 5 or we like 10, right? When you buy a pack of candy, if it says 10, then okay, you're happy. If you buy a pack of candy, if it says, oh, it has 11 candies inside, you're like, dude, can't you just make it 10, right? Your OCD sense is killing you. So same thing here. They won't give you 7, they won't give you 8, they will just give you 10. All right, so we know that each dot is 0.02 second, right? So since we have 10 dots, then we have 0.2 seconds. So now we have the distance and now we have the time, right? So how do we calculate the speed? Easy lah, just 3 divided by 0.2. Okay, as you can see here, 3 divided by 0.2. Now you get 15 cm per second. So the speed of this thing is 15 cm per second. Easy. It's just like up there. It's just that now they already give you this. Now you just want to find out the time and you find the speed. Easy peasy, like seriously. Okay, usually If they give you 5 dots, it's 0.1 second. Because 5 times 0.02. If they give you 10, then it's 0.2. It's either of this one. Either of this one. So it's either 10 or 5. Right? So now velocity is very easy. Okay, let's calculate acceleration. This is a little bit confusing, right? Because we know that acceleration is final velocity minus by initial velocity divided by time, right? Right? You learned this just now, right? You see? V minus U over T. So this is slightly complicated. So just now, we just need to find the speed. Now we need to find 3 things. We need to find the final speed, the initial speed, and the total time. So now it's slightly more, a little bit more work. Right, guys, please help me write something. Something is missing here. Please help me draw an arrow here, pointing to the left side. You guys do have these notes, okay? If you don't, please write on a piece of paper. Okay, so please point to the left side and please write direction of motion. Okay, please write this down. Okay, direction of motion. Right, so what does this mean? What does this mean? Whenever you see this arrow, that means they start here. Wherever the arrow points to, you start there. That means this sticker tape, it starts here. And if I zoom out, can you see what happens to the dot? Can you see what happens to the dot? What is happening right now? What is happening right now? Is this car accelerating or decelerating? Can you tell? Can you tell? Is this car accelerating or is this car decelerating? Is this car becoming faster or is this car becoming slower? Can you see? Okay, anyone? Are they becoming faster or slower? Answer me, please. Answer me, please. Okay, are they becoming slower or faster? Yes, they become faster, right? Because you see, this part is very slow. This part is very fast one. Can I? Okay, really easy. So, please help me label it. Okay, this is the starting speed, right? Because I start here, what? This is the starting speed, right? And this is the ending speed, right? So please write this down. This is your U, and this is your V. Okay, this is your U, initial speed. This is your V, final speed. Okay, and let's look at how many dots here. Let's look at how many dots here. Like I said, don't count the first dot. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing. Don't count the first dot here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually you just need to count 1. Because if the first is 10, then the rest of it will be 10. So every strip is 0.2 second, 0.2 second. Every strip is 0.2 second. Because it's 10 dots, what? Okay, 0.2 second. So let's calculate the U here. Let's calculate the U here. Since we have the distance and the time, so distance divided by time. 1.5 divided by 0.2. So you get 7.5 cm per second. You see? Very straightforward one. And then V, this is the distance. This is the time. So distance divided by time. Right? So you will get 37.5 cm per second. Okay, are you guys okay so far? Are you guys okay so far? It's just doing up here, but you are doing it twice now. We are calculating the U and we are calculating the V. So this arrow is very important because the arrow tells us where are we starting. Because if the arrow is pointing here, now we have to start here. So this is the U now. Right? Gabriel, are you still with me? Gabriel, are you still with me? Okay, good. Right. So now let's put everything together. So we have the V and the U. Okay, so what about the T? Right. So okay, listen here, guys. listen here. Many people think that, oh, sir, the total time is 0.2. Since we have 4 strips here, right? 4 times 0.2, that's my total time, right? Wrong. Okay, wrong, wrong, wrong. Many people get this part wrong. Many got this part wrong. Because you know why? You see, when we count one strip, we don't count the first dot. Right? We don't count the first dot. So when we count all these strips, we don't count the first strip. We don't count the first strip. So instead of having 4 strips, you actually have 3. Right? So the total time is not 0.8. The total time is 0.6. So you see, 4 minus 1, 4 strips. We don't count the first strip. So it's actually 3 times 0.2. So V is 37.5. U is 7.5. Divided by 3 times 0.2. You will get 50 cm per second square. Remember, it's a square because this is acceleration. All right, are you guys okay? Are you guys okay? So this will be this is the easy one. Okay, usually you will have no problem getting U and V correct. It's just that the total time here, you need to pay a little more attention here because it's a little bit confusing. Just a little bit, okay? Just make sure you minus out the first strip. That would do. Right, so can you please try this out? Can you please do it now? Okay, I want you to do this. And please take note, instead of having 10 dots now, they give you 1, 2, don't count the first one. So they give you 1, 2, 3, 4, 5. Now they give you 5 dots instead of 10 dots. Okay, so guys, I give you 5 minutes. Please do these two right now, and I'll give you the answer later. Right? In 5 minutes, I want you to do it right now. See if you can get it right. Okay, are you guys done? Are you guys done? Did you do? I hope you did. So, let me give you the answer. Let me give you the answer. Please check. So, since this is 5 dots, so the time is 0.1 second. Make it a habit and write your time down. It will make your calculation much easier. So this is distance divided by time. So you will get 60 cm per second. Did you get this? Did you get this right? I hope you did. And the next one, this one is, you look at the arrow. Look at the arrow. That means we start here. That means this strip is the U, this strip is the V. Okay, so since this is 5 dots, so this is 0.1 every strip. Every strip is 0.1. So how do you calculate the U? It's 2 over 0.1. Distance over time. So you get 20 cm per second. And V is 8 over 0.1. You get 80 cm per second. Okay, so at least you will get to this point. If you can get this right, you can at least get this 2 right. Now here comes the challenge. The challenge is the time. Right, so you have 4 strips here. You see, they even give you initial here already, right? Okay, and final. So you have 4 strips here. Remember, we don't count our first strip. So there's 3 strips here. 3 times 0.1. So you get 0.3. So just put everything together. V minus U over T. 80 minus 20 over 0.3. So it's 60 over 0.3. I would get 200 cm per second. So this is my final answer. Okay, you guys get this? You guys got this? It's this easy. If this comes out in exam, this question will carry 3 marks at least, right? If it ever comes out, because this part is sometimes considered a little bit too straightforward. So maybe they won't come out. Maybe they will. I don't know. Right. So guys, I have some homework for you. Your homework would be here. If you want, you can do the front part. I don't really care. I want you to do question 6. Okay, the ticker tape one. Please practice more. Question 6, question 7, and question 8. That will be 3 questions. 6, 7, 8. The front part, the distance displacement one, the velocity speed one, you don't want to do, it's fine by me. If you want, you go and finish it. Right? And before I go, guys, here's a quick reminder. Next week, okay, this week is week 2, right? This week is week 2, right? Next week, week 3 is as usual, but week 4 is also next week. That means next week, you need a double class. You need to attend a double class. So next Wednesday, things are still as usual, but you have one more lesson to attend. And when would that be? This is a bit weird, guys. For Form 4 English, it's gonna be on Wednesday, same day, 11:55 a.m. Okay, can you see Form 4 Science Eddie E? That's me. Okay, that would be 10:55 next Wednesday. Okay, same Wednesday 11 in the morning. Okay, 10:55 or 11 lah. That means next week you'll be very funny because you'll be attending the week 4 class first, which is 11 in the morning, and then I will see you again in the evening, which is 5:20 for your week 3 class. So you'll be attending a week 4 class first before you attend a week 3 class, which is like a reverse thing, but that's the best I can put it because my schedule is very full. I cannot choose any time slot else. So this is the class you attend. Right? So pay attention. Next week, 11 in the morning, you attend week 4 class, and 5:20, the usual time in the evening, you attend your week 3 class. So there will be a double class next week, because the following week and the week after that, the 2 weeks, the last 2 weeks of your December is your term break. Okay, it's your holiday. We are not having any class, so you are still having 4 classes for your December. Right? I hope it's clear. I hope I make things clear. So do you have any question? Do you have any question? Okay, if there's no question, I think I will stop here. So I will see you next week twice, 11 in the morning and 5 in the evening. All right, so take care, guys. Make sure to do the exercise. Make sure to do the exercise. I will see you next week. All right, so have a happy Wednesday. I will see you again. See you. Take care. Bye-bye.